Enterprise Architecture Specialist Group. I'm feeling particularly hungover. I introduced John Zachman and Tom Gill to each other last night at dinner, which was rather an interesting experience, and they've agreed to speak next year together for us. So that's going to be quite an interesting event sometime in the spring.
And what should you drink?
Assuming he gets out of alcohol anonymous.
I've probably drank all of both of them, but anyway. So we've got two really interesting speakers today, Paul White and Doug Hackett. We'll spend about 20 minutes for each of the presentations. There'll be a few questions at the end of each of the presentations, and then a wrap-up Q&A at the end, and then we'll go outside and hopefully there'll be a bit of food there as well at the end. Okay. So Paul's going to kick off, finally. Paul's Chief Enterprise Architecture and co-founder of the IT Data Group at Royal Mail Group. I think you've probably all got the sort of crib sheet, so you can read more about it in there. And was, you were at Durham, so was I. So Paul, over to you.
So thank you for inviting me along tonight. I've got a slight confession to make to start with. I'm not actually a member of BCS, so please don't throw me out, and I'll...
You can join at the end.
I'm sure I'll join at the end.
There's loads of people members.
Just wondering.
They still eat the sandwiches and drink the wine.
So I probably need to just explain the title a little bit. The first one is fairly straightforward, Chief Enterprise Architect. Yeah. The co-founder of the IT Data Group is a little bit strange. It's a bit of a thought to something that myself and one of my colleagues did about a year ago when we realised that Royal Mail was sitting really on a gold mine of data, but we weren't going to do anything with it. We were doing statutory reporting, and that's about it. So we decided to merge teams, get a virtual team together, and I'll show you the real structure of that to try and start getting some insight around this. So, a little bit talk overview here, and again, this is my second, never apologise, but my second apology of the night, typical architect. I was given a brief, talk about big data, and I'm going to totally ignore that and talk about data science. But the idea behind it is that we're at hopefully sort of talk a little bit about what value that we're going to derive at Royal Mail from our big data. So there is a slight connection somewhere in there. In particular, the gaining the insight, because it's a slight diversion. When I first started in IT, I started in what's like the proto-ERP, enterprise reporting planning systems. And what we did was, we entered an order and we captured the state at that point, and then things happened, and then we shipped it. And we actually sort of look at the pipeline. It was enter order, ship product, and nobody knew what happened in between. It wasn't that long ago since Royal Mail was in the same situation. A bank, UBS for example, would say, we want to ship out 10,000 letters. So they'll contact Royal Mail and say, we're about to drop 10,000 letters at your Swindon Mail Centre. And we'd say, okay, and we'll take your order, 10,000. And that would be it. That would be our sole record of the fact that we've actually done business together. Now, with the advent of machines that can read our mail, we're putting barcodes on there. All of a sudden now we're getting to a point where we can say, well, we can actually sort of capture those 10,000 coming in, we can read them, we can do an optical character recognition on the addresses, we can see the names, we can capture all of that. We can actually, with containerization now, we can say, okay, we've got this letter that sits in this particular bucket, that sits in this, what we call York, it's these big trolley things that sits within this particular articulated lorry. We've got telemetry on that. So now, all of a sudden, we've got telemetry that's given a heartbeat. So we're seeing, potentially, you can see your letter moving up the M1. Secondly, we've got our posties, they've got these postal digital systems. There's things that you need to sign when you go for a sign form. Again, there's a heartbeat on these. So potentially, we've got, your letter is now walking down your street. We're not saying we're doing this, but we've got potential to do that. And I think this is where the big data comes in, as you all know. It's all about just the amount of data we can get now and the speed that it's coming in and the different formats we're getting, because these are all done by different vendors. It's very confusing. So that's my pitch for why we're saying we do data science. Every presentation you give to outside people, you have to give a little bit about Royal Mail, and especially because Darwin keeps calling me the Post Office, which we're not, we are Royal Mail. Post Office now is a separate company. I just want to give you some stats. So we used to be a monopoly, we're not, which is a good thing now. There are other people that do deliver us mail. Curiously enough, not many people like to deliver mail to the north of Scotland, but we do. We do it 6 days a week, 52 weeks a year. We have an obligation to do that. These are sort of figures we're talking about. So in the letters, we're talking about 16 billion letters per year, parcels just over a billion. We are still the largest distributor of parcels and letters within the UK. 143,000 UK employees. I think it's about that. I think it's around about 150,000 now. So we're a big employer, and we've got a huge bill, 4.4 million bill. So we're very manugistic company. We use a lot of people still to do a lot of things, even though we have got some automation. So that's rolling over the glass. Right, let's get into this. So I call this the ubiquitous Venn diagram. So if we want to talk about, well, what is data science? What is a data scientist? If you go searching in Google for this sort of thing, you tend to come up with this. And is this coming out all right at the back? Do I need to just talk that through, or can you see that? Yeah. So what you tend, I don't claim credit for this. These are depending on the internet. What you tend to sort of say is, oh, it's a magical mix between somebody who knows an awful lot about statistics and mathematics, somebody who's really good at hacking skills, and actually somebody who's got substantive expertise, but somebody who knows the business. Now, this is the magic zone, the data science. We haven't quite got there yet. The reason why we haven't quite got there in our journey, what we tend to find is we're recruiting in this area. So we can recruit people with great hacking skills, we can recruit people with good maths and statistical knowledge. What we tend to find is these people tend to come from STEM backgrounds, and they're pretty much PhD people. One of the first ladies we brought in is a MasterChef's finalist, but other than that, she's a nuclear physicist as well. The last person we brought in, Cambridge graduate, got his PhD at Imperial. So these are the kind of people we're bringing in. So, big tick for these things. But what we need to find is, and this what we tend to find is, we tend to have to support them with this. And this is what we created the data group for, which I'll show you on the next slide. So it's this thing. Eventually, we'll push them out, we'll get them talking with the business as we're doing now, and they will build up that knowledge, but obviously that takes time. There's this weird thing of the danger zone. This is what we tend to find in Royal Mail quite a lot. There's a lot of people who get access to data, and some of them do some really good stuff, some of them do some slightly strange stuff. And anybody who's been a data architect for any longer than a week knows one of the biggest problems is, oh, my report says 1,000, oh, my report says 10,000, who's right? And there's an awful lot of that going on with Royal Mail at the moment, so we're trying to close that down and bring people into here. I've been told not to let you ask questions during it, but please, if any of this, you want to ask questions afterwards, please let me know. So, last thing before we get into a little bit of discussion about what we're using data science for. I talked about the co-founder of the data group. Effectively, it's bringing myself and a guy called Thomas Lee Warren. We went around and we sort of said, okay, you know about data, you know about data, you know about data, we're going to bring you together into a team. And this is where we put the data scientists. We put them into a group called the Data Insight. So these are the people that look at the data, produce some good insight, produce a lot of statistics from that. But we supplemented them. We brought in visualization specialists. So we've actually got a graphic designer with us now who's ready on ClipView, and he can do some wonderful things in there, and things like D3 and things. We bring in developers as well to support them. So all of a sudden now we've got a fairly well-functioning data insight. To give them that substantive experience and that business experience, we've also brought in business analysts and things. We've put them in the business engagement area. So now we've got the ability to go out and engage with the business. These are people that have been with Royal Mail for quite some time, so they do know the business. So now we're getting that substantive experience in there. We're not saying that data scientists can't go out and talk to the business, but what we are saying is that we will support you in that. We'll give you some good business analysts, some good business knowledge around that. We put support around that because Royal Mail, it's a bit of a problem. Royal Mail is a delivery company, but actually IT has to deliver as well. We're all focused on delivery. We've got a CIO called Catherine Durand, who's an excellent CIO. I've got to say that because the camera's on. But she is, but she's very keen on delivery, and we have to. We're a very cost-conscious organisation, and we have to make sure that every person is contributing to that delivery. So hence we brought in a delivery group that's full of other project managers, testers, etc. That looks a lot more like a traditional IT department if you looked at that delivery group. And of course, to give it more structure, we brought in the architecture as well. So I would say it's the data and solution, but it also includes technical architects. So how do we set up, for example, how we do clusters? how do we integrate a lot of that with our Teradata estate and other data warehouse we have. So there's an awful lot of architecture work in there as well. So that's the data group. That's what we're finding is beginning to give us value. I think if we just took the data scientists and plucked them in the corner and said, go away and do some good stuff, they would do some good stuff, but they would be held back, mainly because they wouldn't have the contacts and wouldn't necessarily know, what to do or priority on the business that should be working. So what do? This slide is a little bit sanitised. Again, I do apologise for that because some of it was commercially sensitive, and I am happy to talk a little bit more off record about the sort of things we do. Obviously, I can't give too much information, but I can talk a little bit more about that. So some of these opportunities are a little bit more genericized now, but we are doing a lot of stuff in this. So what do we get these guys doing? Well, predictive analysis, for example, if we were to raise the price of a stamp by a penny, how would that affect sales? If we were to change the box sizes that we allow for particular prices, something bigger or smaller, how will that affect sales? How will that bring more business from our competitors? Will that push business out to competitors? So an awful lot of predictive analysis around that and using the data that we have. Optimization, if you think about it, our organisation is all about that. We have tens of thousands of posters that walk routes, and they have a specific way to do that. They don't just sort of start at one end and walk down. Sometimes we have them going in twos, we park a van, they'll do a route, they'll come back. All of that, there's a lot of mathematics that goes into that to optimise that route, to make sure it's the shortest possible route, it's the most effective route, etc. And we can predict roughly to give to customers what time they're most likely to get the mail. So there's a lot of work that's going around on optimisation as well. Root cause analysis. We all of a sudden see a dip in sales in a particular part of the country, or we're seeing a spike in the number of letters that turn up on a Thursday in Swindon, or the second Thursday in Swindon. So why is that? Well, root cause analysis gives us a lot of ideas about what's going on with that, so we can cater for that. We can maybe increase the shift patterns, we can change the shift patterns. The root cause analysis also, probably on the slightly darker side, if you're looking at if somebody's trying to game the system, maybe we need to put extra revenue protection in a particular area. And actually, once we've done that, we can then go back and we'll say, well, was there anything in the data that led up, and we can correlate to when that loss in revenue happened. So now we're thinking, okay, well, we've done that, we'll create other models and we'll apply that to other areas of our business so that we can predict if we're likely to have a fall in revenue. So again, this is quite smart stuff they're doing, things we couldn't do several years ago. Anomaly detection, like I said, the PDAs, they do have a heartbeat. We have trialled using some of these, and therefore we can see whether or not if they go missing, in other words, has it been stolen, has a van been stolen or something. If all of a sudden we say that a typical route does this, and also we notice that it started to do this, then hang on a minute, it's been misused, or it's gone missing. Again, the sort of things that we're looking at and trying at the moment. Recommender systems, we all go into Amazon, and when we go into Amazon, we buy something and it says, have you thought about buying this as well? Well, that's very applicable to our business as well, because when we talk about customers, we tend to not talk about you and I, we tend to be talking about the UBSs of the world, the organisations that provide an awful lot of mail, so here's 10,000 letters to actually sell.
Junk mail. I get a lot of junk mail. I must spend a lot of money with you people.
A lot of people that say that. My sort of standard response to that is that people would only spend money on things if it works, and it works. So I was more thinking about things like statements and bank statements and things, but so we tend to offer certain products to those customers. Well, what else can we offer them? Can we sort of say, okay, we generally offer you this, and this is like a 3-day service. We could maybe offer you this on a 4-day or a 2-day and give you slightly different preferential rates. So again, this is often modelling, and does not necessarily means it actually gets to the business to do that. What it is it's us looking at our data and saying, if we were to do this sort of thing, what smart things can we do? Some points to consider though when we're doing this, and as and when I've been sort of working in the architecture space of this, a lot of it's probably granite case, but I think it's still worth sort of saying, is that you can't just sort of bring these people in and then sit in with laptops and say, you know, there you go, crack on. You've got to think about, well, what architecture are you going to give them? What systems are you going to give them? Are you going to give them good right on your production data warehouse? Maybe not a great idea, because these guys do some really weird algorithms. Are you going to give them a desk that sits under the, you know, a server that sits under the desk? Well, maybe not, because there's an awful lot of confidential information. You know, we as a group will spend a huge amount of money on enterprise strength systems, securing them, making sure that all the data in there is, you know, is good as what we can. The last thing you want to do is then say, okay, we'll take a huge extract of that and give it to a server over there that anybody can put a USB key in. So there's a lot of things around this. So this goes on to the second point. I read an awful lot in the press that says, oh, I do, yeah, it's everything. It's great, no, keep storage. Whatever you do, put it in there. Well, I'm saying maybe not. Maybe not because, one, it's the real business requirement for that. And secondly, it's like just because you can do something doesn't necessarily mean you should do something. There's a lot of other stuff around it. And you shouldn't rush ahead past your policies. One thing we've been very keen on, one thing I've been very keen at Royal Mail, is that we make sure that the technology doesn't outpace our policies. Because we're quite a conservative, you know, company in the end, and there's a saying that we never want to appear on the front of the Daily Mail, because if we do, it's generally not for good reasons. It's what, you know, Royal Mail has done this. Now we've seen some other organisations end up in the front of Royal Mail, you know, certain supermarkets have done this, certain banks have done this, or whatever, because they've not controlled the data. So all I'm saying is, the things we've learned with this is, just because you can do something doesn't necessarily mean you should do something. Some lessons around that. Get the right team. Hire people smarter than you. Dals would probably say that's very easy for me. But it's true, you know, that there's, I can't remember who said that, there's one of these gurus that said this, but it's true, you know, if you bring people in, make sure they're smarter than you, make sure they're better than you. You can teach them, then you can sort of sit back and watch the magic. We tend to bring in PhDs. We don't apologise for that, for data science, and it's working quite well. Not because there's any sort of cashier that's put on a PhD or any kind of snobbing around that, but basically because these people are grounded in analytical techniques, you know, from day one. So they bring with them that discipline into your organisation. You have to give them the business experience, but they do bring that discipline of verifiable evidence and all that sort of good numerical work when they come into your organisation. Don't forget the fundamentals. A lot of people say, oh, data architects, you know, your days come and go. You know, they have the schema on right idea that you have to get everything right in the data warehouse before you put the data in. And I've got people saying to me, schema on read, don't put your data in there and then we worry about it later. Maybe not. So what do you call a product? Why call it this? What do you call a product? Why call it this? So you guys are calling it something different. So again, the fundamentals are still there. Good old data dictionaries, making sure we have clear understandings of things. It actually increases the need for data architects because you tend to find it having to run around all over the place putting out certain fires. And I almost left this. This is a slide from my co-founder, Thomas Lee Warren, and I almost left this out by mistake. I meant to put it in. He's very keen on the science and the data science, and he's a very interesting character, a very bright person, and he's all about, this is what he instills within the Data Insight team, it's all about, there's no hierarchy, it's data-led. So, you know, if you're just, this guy called Kurt Bourne, I think, is the chief data scientist at Booz Allen, and I follow him on Twitter, and he did this wonderful little tweet recently that said something like, yeah, if you haven't got data, you're just somebody else with an opinion. And that's the kind of approach we're taking. You know, if somebody says, oh yeah, we need to do this, we're saying, well, show us your logic, show us your data then. Oh yeah, that's not going to happen. Well, tell me why it's not going to happen, show me the data. So this is the ethos we're actually putting through. We're trying to get rid of all the myths and superstitions and all that sort of thing and get the data to tell the story. That brings me to the end of formal part of the discussion. I'm happy maybe to take a couple of questions if you'd like, while
Swap laptops.
Yeah, so
While you're taking some
swap the
questions.
laptops, and then I think we're going to join.
Yeah, that's right. Let's take a few relevant questions for the presentation. I've got one, which was the organisation. So you've got your data group. How does enterprise architecture fit within that? Is it a subset of that? Is it alongside it?
It's a Venn diagram. So then enterprise architecture sits by itself, and then we have the data architecture team that sit in both camps. So at the moment we have the data architecture. Well, the data architects work well within the enterprise architecture team, but they also are embedded within the data team as well. So they'll go to their management meetings, they'll go to their development meetings. So, and actually that works quite nicely as well, because now and again enterprise architects, you know, you're working down in tower somewhere, but we don't, and it allows us to get really involved in the weeds to see what's happening down there, so we can influence projects as when they come along.
And how many have you got in your enterprise architecture team?
In the team in total,
Yeah.
16,
Right.
but we don't have technology architecture. Technology architecture is a separate group, about 8 or 9. So what I have is business, data, the application, and integration. And we have technology, so there's 16 of us there. We're looking at digital at the moment as well, wondering whether or not we need separate digital ones.
Where do you get all the software from? You develop your own modelling, or you buy stuff in, or you outsource it?
Well, first of all, we
Because
have...
obviously there's a lot of analysis there of all that
Yeah.
data.
Traditionally, we're an outsourced person, and also we tend to sort of buy the Oracles and the IBMs. So you go take it back a couple of years, and it's very much an IBM. Look at Data Warehouse, IBM, Teradata, SAP Business Objects, all very
Oracle.
good standard. All very good standard stuff.
Yeah.
What we've found is that when we bring these data scientists in, they're saying, no, we Python, give us Python. So we looked at, first of all, give them R, and they're saying, that's okay, that's Python. So actually what we tend to do, we tend to give them the architecture that allows them to do whatever they want, put the boundaries around it, but then we don't inhibit them using whatever tools they want. And they're just out there bringing in all sorts of libraries left, right and centre. I mean, it is a challenge just to keep a little eye on them, but essentially we don't want to constrict what they're doing. So Python, D3, so a lot of it's open source, because that's what they've had to use in their past lives. That's what they're good at.
So D3 is a visualization library you use.
Yeah.
Do you do any real-time analytics, like real-time dashboards, so you can actually react in real time?
No.
It's all text.
There is some thoughts about that. There is some ideas around. I'm not too sure it'll ever be real time. It might be somewhat what we call near real time. So we're looking at things like products that might be when is your parcel due, that sort of thing. So reacting to where things might be and things. So we're looking at ideas around that, or in machine processing areas we might do a little bit of that. But at the moment we haven't done any live real time dashboards.
Can I ask a question? So you've got some solution architects.
Yeah.
The primary focus is on the data side of things. But what if there's a new capability that PDAs, for example, that's not manipulating data, just location-based tracking?
Yeah.
You know, how do you initiate a project where it's not data-centric? What are the other solution
There's other
architects?
solution architects.
Right, okay.
So it's a little bit like we've striped some of the architects out of the enterprise architect.
Right.
We've got a quite well-formed solution architecture team. And what we do is we carve a certain amount of them and say, you're now matrix management into the data team as well.
Right, okay.
And we've got a whole business engagement model for that as well. We wouldn't necessarily put a solution architect straight in. We'd actually put one of the business engagement people in first.
Great. Paul.
Thank
Yeah,
you very much.
Thank you. Very good. So, and thanks for coming in on time. So that gives us more time at the end. This evening came out of a casual conversation back here in June when James Park is at the back there and a few guys were just sort of chatting about this whole big data thing. And I know that enterprise architecture, there's probably lots of other parts of the BCS that worry about big data, but I do think it's a very important sort of dimension to this. I think Paul's presentation was really useful. So we're now going to go on, and James has nominated Doug Cackett from Oracle, because he hasn't got the courage to get up here himself to talk about it.
Too
And
right.
Doug has kindly agreed to talk from a sort of vendor Oracle perspective of what Oracle's doing, and it was interesting, this little conversation we had about that. So it's mixing in another set of ideas which we can discuss in more later. So over to you, Doug.
So actually, from Paul's conversation, I think that the thing I really, really liked about it was when he talked about you should always employ people that are brighter than you. So at this point, I'm going to point out that James is obviously my boss, so hence the reason I got anointed from a distance. Doug will do it. So, in fairness, actually, so my background at Oracle, I started off in the UK practice about 20 years ago, working in Oracle, and then was lucky enough to move to the States and do some global work, working across sort of organisation, if you like. Sort of doing the methods work for Oracle as well around information management, data warehousing at the time, if you like, and BI and all those components. So I've, in my sort of career in Oracle, it spanned sort of, as I say, the last 20 years, but fortunately, sort of completely different type of requirements that have come through for all those customers. Still chasing the dragon, I'm still trying to deliver information management. In fact, if you think back to Paul's Venn diagram, the questions I really want to ask, or answer, or even try to answer tonight, is really about what do you do about people who have got the technology and the skills, if you like, to do the hacking? How can you keep your enterprise systems in pace with those guys? But you also need to feed them data, don't you? You need to get that data to them so they can deliberately drive your business in one direction or another. But at the same time, so you don't want to constrain them, but at the same time, you want to make sure they don't run away too fast, right? Because the rest of the business, as I'd like to explain, has to keep pace. Because if it can't, it's really not going to be sustainable in the longer term, right? So, now, Dawn did also say that you were a noisy bunch, and you all look almost as nervous as I do at the moment, right? So it is okay to, ask questions or whatever you'd like, apart from James, obviously, who, unless it's, would you like a pint, Doug, in which case the answer's going to be yes anyway, right? So, let's start off by making sure it works. So look, should we start off by, and so I'm going to kind of try and, so big data to me means everything and nothing. It's such a fungible term depending on who you want to talk to, okay? So big data to me is a bunch of technologies, and it's really not very interesting, frankly. It's more about, for me, it's about information management. So it's about how do we, what technologies, what architectures, what business processes and practices, what governance procedures should be put in place so that our organisation can sort of identify data, can optimise the data and maximise the value we can get from that data. Now, the implication is it's all data, ideally, okay, and it's full life cycle, throughout, all the way from identifying data all the way to actually disposing of the data once it's appropriate to do so, right? Now, I've not been able to put it any more succinctly probably than, this is adapted from Tom Davenport's stuff, so many of you probably would have run into him. The original article, I think, was about 2005, was it? Oh, no, this is Harvard Business Review, Competing on Analytics, I think, was the... So what Tom really did is he stood back and he identified that some organisations were really, really, really good at data. So probably like Paul's group, they managed by fact, so they acquired people into the group that were factually oriented, and they started to develop systems which would help them deliver those facts, if you like, into the organisation. And then the organisations themselves kind of transformed, and they tended to outperform their peers in the marketplace, so they, higher levels of capital, PE, and everything else, right? So they could be seen to be above their competitors. And it was seen as well to be a sustainable competitive advantage at the time because other people could not do this, right, with analytics. So he coined that Analytics 2.0. Now the implication is 1.0 is where most organisations are at. So this is just reporting, isn't it? Right? So James and I actually have just been working with a retailer, for argument's sake. They actually spend quite a lot of money, but they had in their data warehouse, which was meant to be an enterprise data warehouse, 32,000 tables, okay? 32,000 things, and you think, how can I get value from that? I mean, how can I understand that? It's just a nonsensical way to be. Now, to some extent, the reason they had 32,000 things and it was a mess down here was because they were trying to do this, but without the architecture underpin. Okay, so what they did is they said, new problem, let's have some more tables for that, because it didn't quite match what they were doing before, right? So we didn't have any governance. The other extreme is also true, of course, where I've also seen people held back here by inappropriate governance, such that any change to a schema, for instance, in a database takes 12 months to work through. Now, that again doesn't make any sense to me. It can't happen, right? You've got to balance those things. More recently, Davenport's gone on to say, well, if we're managing by fact, if we could operationalise those facts, if we could take a decision, let's say it's a website. Let's say James, for instance, is on a website again, and we want to make some kind of recommendations. Now, James spends a lot of time looking at things like Debbie Does Dallas and those sorts of things. I'm talking
filmed.
Yeah. Okay. Obviously, they're educational content. So, but we're trying to make a recommendation to James, right? Okay. And yeah, I'm not going to carry on that conversation because that's really funny. But if we could take so if it was just a question of does James need help? Normally, yes, right? But does he need help? How should we route that call if it's inbound into a call centre, for instance? Do we know what language he might be speaking? What kind of a problem he might have? Can we route that? So the IVR could route him automatically down to what recommendation could we actually do something in terms of the call centre and the call centre agent. So there could be any number of 1,000 things, parts of that process, which could be aided by some automated decision-making process. Okay, all right? Seems to make sense, doesn't it? So here, this is great. We're informing our business process, but if we could move over there, we can start to monetize the information, the value from the information that we have. Okay, all right, brilliant. The implication on the right-hand side, though, is we need to be able to do fail fast, don't we? We need to be able to get data fast. We need to explore the data, as Paul was talking about before, really quickly. We need to bring the analysis into the data so that we can go around. We can do test, do, learn. And the more we can do, the quicker we can do it. Say, Paul's got a finite resource, 10 people working for him. If we could actually process that data 10 times faster to deliver the results that we need, then we could tackle twice as many things, or 10 times as many things. Okay? Right? Again, that makes sense, doesn't it? Yeah, that's what we're trying to design for, surely. So, so to change pace slightly, though, before we get there, let's talk about big data for a minute and the kind of momentum around big data. Okay, or the kind of, it's not just big data, but information management more generally. Okay, and I've broadly put it into these 4 buckets. So the first of these is, because of what we've just been talking about, because we're now linking operational and analytical systems, there's an implication, isn't there? So we're blending these systems together, but we shouldn't lose sight of the fact that these 2 systems are 2 systems. So the non-functional requirements change, don't they? If it's now important that we can resolve a query really quickly because a call centre agent is waiting for the answer, then you better make sure your analytical systems are in step and have the same kind of non-functionals as your operational systems perhaps. They can't just disappear because someone's rebuilding a whole bunch of things in your warehouse or backing it up or whatever. Okay? So that's the first thing. The other thing we've found is that a lot of people have invested hugely in their data warehouse technologies, the data warehouse platform, but they might have selected the platform, say, 10 or 15 years ago, and that was great for them, but it's not great for now. So they've continued to invest in the platform, but of course, it's probably at a point now where they need to step back and understand what they're trying to deliver from an architecture point of view, and maybe rethink that architecture. And that's what's happening. So big data is a new opportunity to reconceptualize the way that we're delivering information management. Okay? Externally sourced data and mashups as well. This is really key. So probably key to Paul's group of people. It's not just the enterprise data that's there, but maybe other sources of data as well. So I want to get, say, weather data. Maybe weather data has some bearing on the number of people that turn up for work in a post office in a seaside town. I don't know, but the data will be there. But the question is, where do we get the weather data from? So what sources can we get it from? What's the cost of that? What's the reliability and quality of that? Now, that's also a really interesting point because, wherever I've got it, shift between truth and trust. So your enterprise data, right, you can nail it down, can't you? You knew where it came from. You understand the value chain that that data is connected to. You have a responsible party. You can say, that data's poor, look, I know who to go and call. But what about the weather data? Where are you getting that from? If it's the BBC, okay, we can say that's trustable. But not always, right? Okay. Does it get refreshed every day at the same time? Is the occasional hurricane coming through or whatever? So there are differences. What I'm saying is that actually, weather data and sourcing data from outside, there's a slightly different model. You can't really have a trust-based, you can't have a truth-based model. It's more about building trust in the data through use, isn't it? So, polyglot persistence, again, this is a recognition of the fact that it's now not relational or other. So it's relational, you might have a whole bunch of stuff in JSON, in XML, XBRL, you might have nodal stuff, you might have graph data, those sorts of things. So it's not just one thing, it's actually many, many things, isn't it? And probably you're going to have to extract value from all of those things and combine those things to truly exploit the data that you have. So the question is, should each one of those things be in a separate store? Or we think not, and I'd like to explain why. But then how can you have those models in a single store, or fewer stores, and still actually curate them all? Okay, so that's a really interesting question, I think. And it's one that's changing as we go through, right? So there is because of, we're going to look at the Hadoop Zoo in a little bit, but actually if you look at just Hadoop, let alone the NoSQL and other environments, document stores as well, there's a massive range of software available, they're freely downloadable, right? Although you have to obviously pay for enterprise support. But there's a massive range in architectural patterns then you could implement. The question is, which ones should I rely on? Which ones are going to be there tomorrow in a few years' time? But we were talking about it before, just saying my son has just graduated as an engineer, right? And he's working on Crossrail, his first job ever. He's so excited, or dad, And
You're not old enough.
oh God, I wish that was true. But he's the design life for Crossrail is like 800 years. It's amazing. But more impressive for me is that the untouched, so zero maintenance design life is 40 years. So they can't gain access to the tunnel again for 40 years, okay? Or they have to pay, and the pay is painful. So, it's interesting, isn't it? And we should be thinking about these things, I think, when we put stuff down. This, for me, is also really interesting, and this is really key to it, okay? And I think Paul touched on this earlier as well. So, Gartner have got a really interesting model. It's something that we've been talking about in Oracle for many years. The reference architecture we have actually dates back 19 years and has been incremented and developed in all those years to keep pace, right? But what's interesting is, or Gartner at least talked about this bimodal approach. So the idea of a repeatable, robust, curated, I know what it is. When I talk about customer and customer counts, I know how many customers. Things that I care about, I know how to count, right? But there's also this other model, so stuff that I don't know about, and that was the discovery thing that we talked about before. So there, we want agile. We want to be able to get to it, and we don't know what we don't know yet. So the way we're going to go about finding those things is different. It can't be the same. We have to apply lighter governance, perhaps. We have to be able to do things, new tools we have to be able to approach the data with. New data we have to be able to get hold of. Okay? So we have to design around both of those things. But if we can't keep these two things in step together, we're going to get drift, and then we're going to build up architectural and technical debt, which again, from an enterprise architecture point of view, is very definitely no, right? Lastly, there's a shift in budgets and power towards the line of business. You must have seen that in what you do, I'm sure, right? Okay, a few nods. And truth and trust we've already talked about. And then the need for rational governance. In other words, we can't have a single model, governance model, that fits across mode 1 and mode 2. It has to be more adaptable than that, we think. Okay, we have to design for that. Back to Paul's problem. So imagine Paul's being charged with, so, you know, his website again, right? One of his analysts now has been charged with a problem, which is there's an abandonment rate. The abandonment rate has gone up, specifically with people viewing Debbie Does Dallas videos on online or whatever it may have to be, right? So we start off with that as a problem, and this is what I'm trying to picture here. Is really this is business value, or it's our understanding of the data, okay, versus time. So Paul's analyst, his data scientist, is going to get maybe the weblog data to start with, and to make any sense of it, is going to have to sessionize the data, start to analyze the data through. So we know that's a session, we can count that. Okay, what they're looking at, or okay, what page were they looking at? Well, we've got a page ID, so maybe we have to enrich the data. Okay? And then once we've done some basic enrichment of the data, we're maybe going to start box plotting out, look at some kind of correlations in the data, maybe through graphing, maybe through some statistical methods. Okay? So as we do that, we're kind of investing our time, and we're learning more about the data, aren't we, through that process. And sooner or later, Paul's analyst might go, hey, I found something, right? I found something that's really great. Okay? So Paul's going to discuss it with him, and maybe there's an opportunity to monetize it, or something of importance that we need to track from now on in the organisation. Could be as simple as that. Okay? So that's what this second phase is. So we've gone from discovery through to this kind of monetizing or commercial exploitation, I call it here. And really there are two parts to that for me. Firstly, can we automate the decision-making process maybe? So maybe that's the recommendation engine or some kind of business rules that we're going to implement on the website to identify this pattern again, and then we're going to change the behaviour. Okay? And the second thing we need to do, given the fact we've just changed our business process, so we're saying present this page or that page, we want to be able to keep our BI systems in place, or in step with that, don't we? So that we need to know that the decision was a good one. So we're going to have to do A/B testing across those groups. So we're going to have some control groups. We're going to continue to do A/B testing. Okay? And also, we need to understand when the model that we've built has started to decay. So maybe we need to rebuild the model. Okay? Yeah? Does that make sense? You're very quiet still. Okay? Makes sense. So I'm just saying it's not as trivial as, discover stuff, ignore it, or discover stuff, then do stuff over here. I mean, it's BI and it's the next step, which is operationalising it to get true value. So what's the problem with that? Well, the problem we have with it is this, right? The problem is that there's a difference between what IT would like to happen, that's us, of course, by the way. This is the classic waterfall life cycle, which goes, you've done some brilliant stuff, you've done some great discovery, we now have to do some software development. Oh, we're going to put it on our backlog, we'll come to the top sooner or later, and then we need to do requirements gathering, then we need to do detailed analysis, then we need to find and procure hardware and software, and then we have to blah, blah, blah. This is really painful, and the problem is that IT are in the centre of that discussion. Okay? From a design principle point of view, surely, what we really, really need to do is we need to give Paul's team all the software and the data they need to do more in a shorter period of time, and to tackle harder problems. Okay? And then we also need to kind of minimise this step, don't we, the governance step. So Paul talked about maybe his team might using Python. Okay, it was Python, wasn't it? I think. Okay, so Paul's team want to use Python. Fantastic. Are you going to implement Python in a production system? Probably not. Okay, because it's really, frankly, not efficient. Okay, so I would rather do it in a set notation. So maybe we would have to recode. Maybe if you used R instead here to do some of that analysis instead, we could implement it in a production setting. But we'd have to make sure that you've included, say, just error management, just standard error management in there. Now, Paul's team, not good at error management, my team are brilliant at it. So we just add those top and tails. So it's just about doing basics, really. But if we can design and develop systems that could accelerate that, that would be good, wouldn't it? Yeah? Right, okay, so this is what we definitely don't want. We don't want skunkworks, we don't want shadow IT developing, because that's bad, okay, and then you lose control and you don't have governance. We want the bottom piece. For us, this is our conceptual architecture. So let me talk you through this really quickly, because I'm running on as usual. So let me give you an example. This comes from a bank we worked with down in Spain. Fantastic bank. They failed the EU audit on their data, frankly. They could only get 20% of their data out of their systems, locked in a mainframe, really horrendous problem. Unemployment rates hit 45, 50% for some of their segments, and they couldn't basically say whether someone was employed or unemployed, okay? So really, really bad start. They had done a lot with their customers about extending the value chain of the bank, so you could go and get discounts in the bank. They had relationships with all sorts of third-party organisations and things like that. So they'd already developed up some website capability. The CEO was driving this transformation, a really fantastic guy, really, just a brilliant guy, really. I'd love to work for him some more. But he talked about, he'd just been skiing, right? And he said that at the moment when he passed his credit card to pay for the toll booth, going and up to the mountains in the winter, the bank should know that he was going skiing. Because he's skied before, he's got it on his profile, he'd been visiting the website looking for, it's pretty obvious. Or maybe he's unemployed or overdrawn. Maybe the thing to do is to extend an overdraft offer to him instead. But it was that compelling moment, right? So at the time the card was swiped, not a week later, a letter through the post. Okay, so that's the first thing. So we've got inbound event, and we've got an actionable event here, which is an offer, an SMS, because he's already signed up for it. Okay. All of that, I'm going to argue, all of that data, plus all the rest of the enterprise data, is going to flow into our enterprise information systems here. And probably it's going to have, some data is going to be different to others. So some data we know a lot about. We know about all the stuff that we curate already. So that's going to be in our enterprise information store. But there's going to be other stuff that's going to be maybe in this data reservoir that we know very little about. Okay? But it's got potential value for us as a business. After all, many of the problems we have in the classic data warehousing sense is when anybody changes their mind about what they want on the right-hand side of the diagram, i.e. I want this new report. It includes new data, or data that you simply haven't got in your warehouse. You end up by having to go all the way back to the ETL teams and the source owners to get the data. Horrible system. Okay? So this is potentially addressing that. We've got reporting, and we've got some kind of data factory engine which is going to simplify and abstract above standard ETL to simplify the movement of data. Okay? Lastly, below this execution line, we've got this innovation capability. So, and the innovation system is about getting the data, doing the discovery that Paul's talking about, and then moving that into a production setting, which is what we just talked about with that hockey stick graph, right? Yeah. Frankly, the most impressive thing about that, from the Kaisha's point of view, is that they went from zero knowledge and understanding of Hadoop to a full production system in 4 months, including about 800 or 1,200 source extracts from mainframe. Okay, so PL1, MQFTE, real-time replication of data into Hadoop, into Exadata, and off into their VR systems. Yeah.
So effectively, they took the system of record of that back, they copied all the data out.
No, they didn't do a full system of record, but certainly all the customer records, all the transactions, so a system of reference, effectively. Yeah. But it was the bulk of. They were really moving away from the mainframe, so you would naturally expect, I think, probably in the next couple of years, for it to be a complete system of record in the warehouse, or in the warehouse, really. It was not the so obviously the core banking system will remain the core banking system. Everything downstream from there would be.
The follow-up though is, because I seem to work in the banking industry,
yeah.
What I tend to find is a bank will have a system of record, which they love and cherish,
yeah.
and demand to keep for 7 years.
Yeah.
And they'll get to 7 years and realise there's still something in it they want to keep, and demand to keep it for another 7 years.
Yeah.
And end up with this constant collection of stuff, which seems to always get bigger.
Yeah,
so
absolutely right.
A view of going, okay, well this New.
We're going to talk about that in a second. Obviously, I started really late. Paul was really late. So I just got 2 more minutes. So this is a way of saying, look, and this is pretty obvious that actually, if that's the conceptual architecture, the projects you start with may be completely different to that. But this is enterprise architecture. You want a view about what the future state will look like and what you're going to fill in. Correct? I mean, that's really what it comes down to. And we've seen all of these kind of design patterns implemented, depending on scope and budget and sponsorship and all sorts of other things. So, Discovery Lab, the obvious example we've done a couple of years ago was, in fact, it came up recently, wasn't it? The prescription frauds and stuff like that. Did you see anything in the paper about the amount of money wasted in the NHS because of prescription frauds or those sorts of things?
Yeah.
So we had a project. You can't solve the NHS's data problem by bringing all the data together. But what we did know is that data science could help us address some of those fraud problems. So that's what we did. We basically created a data lab as a starter for that, to basically do that analysis piece. So that's the starting point for what they're building out from now. But every one of these has its own case. Perhaps, in the case of a genomic problem that I worked on with a customer, it was cheaper in the past for them to throw all their data away than it was to resequence the data. Okay? Oh, sorry, so to keep it, more expensive for them to keep the data than it was to resequence. Even in those days when sequencing was really expensive. Now, of course, they keep all the data, right? So, because basically the function point hasn't gone up, the cost to store definitely has gone down. This is our logical architecture. Now, we're not going to go through this today, okay? So, broadly speaking, this is a classic abstracted architecture that is going to go through that process we've almost talked through as well, which is, okay, I've got data, I don't know anything about it, I'm investing in it, so I'm going to maybe do some quality management on it, I'm going to do some domain quality governance, and so on and so forth through the process. Maybe you're aggregating the data, so you're optimizing it for query. And all we're doing is managing that in various layers. What this does cunningly do, though, is it tries to balance the cost of storage and management from the cost of query, if you like, or interpretation. So you can argue that you can shove data in really, really quickly into your raw data store, let's say that's Hadoop, but the cost to query, you can, if you looked at a full, cluster, maybe a 20-node cluster of Hadoop, you can probably only support 10 concurrent queries out of it in a reasonable performance, right? Whereas you could support probably 20,000 queries out of one of our Exalytics platforms. So it's chalk and cheese, and what we're really doing is saying, well, okay, but we can store here, but maybe we invest in the data as we're starting to improve quality in things. So as you go up this route, quality improves, and also your user concurrency. Okay? We can do much more on that if you like later. This is to one of the points. Again, this was developed actually for a bank in the UK. And we were having discussions around where is the best place for this project. Should it be Hadoop? Should it be in the relational world? This was a trading platform, actually, if you're interested. And we just created a range of dimensions to try and have that discussion in a rational sense. We said, well, is asset compliance really important to you or not? Is tooling maturity important to you or not? Because if the tools aren't very mature, the implication is the cost of ownership is going to be much higher. So is that going to affect you, yes or no? If you're on the cutting edge, if you're pace layering and you're in the innovation world, then that's less important. But if you want something that's sustainable, of course, it's very important. So pace layering also comes in here. So what we did is we created some reference model, reference design, and then they said, when they plot each new project through and say, well, it looks like that, well, we're going to implement it on this technology or this one. So it ceases to become, a discussion. And the point there I'm making on the right-hand side is that, data now, we're talking about automating the process, the flow of that data, the life cycle, maybe through from in-memory, or from Hadoop, if you like, a non-relational store, through to in-memory as it's being accessed, you find value in it, maybe back out to archiving data in the longer term, back to Hadoop, for instance. So in Oracle, we've now got automated processing just coming through, which allow you to push data automatically, archive it into the Hadoop platform, but still query it. And then, lastly, of course, you can deploy it to the cloud. So, we've got cloud models for all of that stuff as well. Last point, honestly. And this is a big thing, what I wanted to do is try and draw the distinction between different kind of models of forms of access for a Hadoop cluster. So we've got all of our web logs over here, okay? And we've got our relational data over there. So, and there are three broad ways of accessing the data, right? You might say, well, I only want an aggregate of the data. So I'm going to store all of my trades, for instance, on the Hadoop platform, and I'm going to create, sort of position. I'm going to calculate position and move that position in a trading platform onto my relational store. Or I might just have my web logs, and I'm going to count how many visits by whatever you want, by day, by hour, by site, by whatever. And I'm going to move all of that aggregate data to the relational platform, and I'm going to query it there. Okay? That's one way of doing it. The problem with that, of course, is it's really good for fixed mode 1 kind of access, isn't it? Where it's fixed and repeatable and robust and efficient, but rubbish as from an agility point of view, because you've got ETL involved. Any new problem is going to involve new ETLs. Okay? Second way of doing it, which other people are doing, is they're saying, well, maybe I don't have to do that. Maybe I can actually start to federate the query instead. So in this model, I can ask a query over here, okay, and then I can fetch all the data from Hadoop, and I can bring all the data into my relational platform, and then calculate the query there. Okay? So that works really well. It's very agile, but of course, if the data gets big on this side, clues in the name, big data, of course, right? If the data gets big over here, then query efficiency on that side is relatively poor, because all the processing happens over there and very little over here. Okay? Oracle's approach is different to that. So what we do is this, really. So we've basically taken the Exadata processing we do, and we've pushed all those brains into the Hadoop platform now. So basically what happens is you run a query over here, on the right-hand side, and we will push the query predicate processing down to Hadoop. Okay? So we also push down things like XML processing, so XPath processing, for instance, in Hadoop, or spatial and graph into Hadoop, and all sorts of other things. And then we only bring back the rows and columns we need on the right-hand side. So we only bring back a very limited set of data that's required to resolve the query over there. So the advantage is concurrency, really, and performance. So we're franchising it out and getting basically all of the cores of the Hadoop platform to do their work, rather than in batch. Okay? Let's skip this. The only observation I've made is we have people almost full-time managing our understanding of the Hadoop Zoo, the ecosystem in Hadoop, for instance, right? And it changes very rapidly. So in this particular case, if you went back 2 years, we were using MapReduce, we were using probably Flume to get data into a Hadoop cluster. Now, we went through a period of using Kafka instead, slightly different model, and now we're using Fafka, which is that combination of Flume and Kafka, which is a much better model, frankly. Okay. So it's changing so frequently, though. What we now do is we're kind of abstracting above that. So we're using, again, ETL technologies, they're new, which kind of allow us to abstract above. So it's not rocket science, but it is more expensive, clearly, right? I'm done. I'm sorry it's a bit of a whirlwind. But before you do, can I just... The last point here is that, this is all written up in a white paper. I'd like to tell you it's brilliant, maybe because I wrote it. But the other thing is that we run events for customers and for partners. So it's just a full day, it's architect to architect, just PowerPoint, free zone. There's no PowerPoint, it's just whiteboard, right? And it's a discussion. So if you'd like to, there's a reference at the bottom there, and there's no product discussion at all through this. So it is only architecture, okay? And you'd be more than welcome to attend if you'd like to.
How much is it?
Hmm?
Is it cost?
Zero cost, absolutely zero cost.
Any drinks?
Yes, absolutely. You need enough caffeine to keep you awake for the entire day. I think. So coffee, tea, and cakes.
I think they're not PowerPoint, they're something.
Yeah, well,
Great.
that's not bad.
Thank you. So I'll spend 5 minutes just with Doug on questions relevant, and then we'll get both of you up. That's all right. So any questions specifically for Doug on his presentation?
Not you, James. Are you sure? It couldn't have been either that succinct or...
It's very good.
It was fast flowing.
Sorry about that.
So Paul, why don't you come up? We'll just...
Yeah.
We'll have a look about trades.
They all seem very data-centric.
Very...
Very data-centric.
Yeah.
We talked about the ETL. What about the challenges where the data scientist comes back and says, actually, we need these other variations of data, which may be untrusted variations of data, and that there are also differences in the data which are required. Because that's the typical data scientist challenge that you need to think about as part of their whole data ingestion problem.
Okay, so if you went, so the crisp data mining method, for instance, so you start off with the business understanding, the data understanding, don't you, as those two core building blocks. And there's always that negotiation between, you know, what data do I have that I could help resolve the question, or how can I break the problem into something that is solvable within the realm of what we know. And that's maybe the starting point, and then there's the data preparation, modelling, and then analysis kind of phase. And ideally, you should, before you get to the initial analysis, you already would have understood that the data quality is too poor, you need to supplement it with other data, you need to go elsewhere.
No, it's... So if you look at rotator analysis,
Yeah.
really simple example. So you're
Yeah.
taking all the fixed engineering stuff coming through, you know what that is, it's obvious because of the data. But then you start to look at the behavioural pattern information,
Yeah.
you're starting to look at what screen scraping is starting to add to that.
Right.
So now you're starting to add in the non-STEM logic,
Okay.
so it's those aspects. How do you factor that in?
So I think all we're doing within the architecture surely is providing a platform to get that data very quickly and fail fast very quickly. So what we're trying to do is to sort of accelerate the time to where someone goes, aha, we've found something. When it's not maybe the entire answer, of course. Maybe it's just the first iteration of that. Maybe we need to go get some more of that data. We haven't. So again, you know, James, I know, comes from the retail perspective, and I worked for some time with James as a kind of customer. And what's interesting is when you find out about, say, loss prevention in retail. So often it's people tend to steal, for instance, from a till just before they go off shift. It's a pattern that's relatively well understood. So how can we sort of get data, whatever data is, to try and resolve that? So we've got a hypothesis. You know, how can we search the data we have, maybe camera data as well, to try and, you know, overlay it? I don't think there's an answer to that. But as architects, we've got to have a platform which is agile, but also be able to recognise that we need to keep pace. So that mode 1, mode 2, I think is really important in our design. Also, it has to be fully scalable, because we really don't understand the data that's going to arrive, and we hinted at it, but, well, what if, you know, now because of our success, the data's growing really fast, but we've also got it plumbed into our operational systems. Ooh, that's a problem. So how do we double the size of our platform so we can manage the next 5 years' growth without taking an outage? So there's a lot to the physical architecture that we need to think through, I think.
The retail one's a good one because you can get pass-through on beeps measurement.
Yeah.
But you can also get product identification on the beeps to then work out the actual correct value goes through.
So once I give an example of when we were working on it, so we get every time that the EP process is used, there's a little dome in the ceiling and pointing towards you, and the flash is not pointing towards you as a customer, flash points towards the cashier,
Yeah.
right? So we can see what money they're handling. Yeah, so maybe £10, £20, £50, whatever, etc. Alongside that, the EPOS system is actually feeding XML feed through to the camera. It's alongside the digital camera, so you can see this person's doing this transaction stuff. So whilst you might have the EPOS running, for example, typically the vendor to the enterprise data warehouse in a structured manner, there's also the video systems that are providing XML data that are actually being stored feed, as it were, for example, and then pull it in and dump it in such a format that we can bring it together along with the structured data, which shows all the, the cash transaction, the receipt transaction, all that kind of stuff as well. And that's how we kind of address
It's not just end of shift, it's also, as your mate comes through, there's a bottle of champagne
Yeah.
through that
Yeah.
isn't being read and all those
And
things.
an employee collaboration as well. So they tend to always use the same till, the same time of day, with their friend, and so there are an awful lot of things that we actually understand, but you have to prove in the data. So we understand something of those behaviours, but of course what we're trying to do is to find new things that we didn't know about as well by extending that.
But it isn't just data, it's data and content.
Oh yeah, absolutely. Sorry, when I talk about data, I think of it as just
And many people, when they look at their existing systems, it's looking at raw data and looking at what's the new context for our process, location-based.
Yeah, well, to give you another example, if I might. So if you look at the telco kind of example, previously we always did CDRs and call data records. So you'd have a single call data record. Probably there were 15 or 20 call data records which made up that CDR that you're looking at. So you've got when the call started, the handset information, and when the call terminated, and something of the routing. But now, what's more important for most people is, when they're watching Debbie Does Dallas, on their phone, right, is the buffering events that you're having. So actually, all of the network data that we previously would have thrown away because it would have been too expensive for us becomes our customer experience. So how do we take that data and add it to all of the other stuff that we've got with customer experience? And that becomes really important. What we're trying to do is to do more with creating a DNA profile, about how we have delivered services to you, and that includes everything, right? So that we can then transact.
Network quality signal.
Yes, yeah. So there's a lot in that, isn't there? And so it goes down to how we solve the network problem, all the way down to latching between 2G and 3G and all sorts of other things, or up to customer and the customer experience and apologising for the poor service or trying to sell them a new data plan. No point in selling, James a new data plan when he's at home because he's got terrible 4G service. So sell it to him when he's in town, when he's got good 4G coverage. I mean, it's not rocket science, but we've not been able to do it up until now.
So that's just a quick question. That sort of model presents a bit of a problem because you've got geographically dispersed data being generated and lots of it, and you only want to be able to get that data when there's some sort of event that's outside the various parameters. So in your case, if the buffering is too long, you want to be able to then investigate that particular area. But the rest of the data, when it's within the parameters, you don't want to know about really.
Yeah, so there's a life cycle for the data there. So it's a really good example where, let's say, the challenge that we had, we are, believe it or not, consuming 300 billion transactions a day, and each one of those transactions has got 450 measures across it, up to 450 measures. Now, even if you just count the KPI data for that, the 450 measures times 300 billion, it's in the petabyte range virtually. It's a lot of data. But what they needed to be able to do from a network standpoint, let's say there's a bomb alert at Heathrow, then there's natural congestion on the network. You need to be able to identify that as a problem and mediate, so you need to kind of start stopping people watching Debbie Does Dallas so that you can actually take phone, they can do phone calls and browse other sites and those sorts of things, finding hotels. So the network itself has to react, and that was the event thing. You remember when we looked at the conceptual architecture? So we ingest the data, and the event management then is at the network layer for that. But then going on from that, we have to manage the data. So we've got intraday analysis of all that data. So Paul and people like Paul, the team that Paul would have, could then do what's the impact on customer, what's the impact on our network, how can we avoid this in the future?
I'm just curious as to what the architecture is for that, because it's not going to fit a Hadoop centralised Hadoop cluster.
Oh, it does.
It's going to be.
Oh, it does. Well, we've landed the other way around. So we've basically, what we're doing, and the argument I kind of didn't make, actually, the spider diagram that I put up that said, choose where you land data. Well, what if you could put your arms around both of those and say, well, it doesn't really, where I land data and where I process data could be different things. So in effect, what we're doing is creating a single cluster across our big data appliance, our Hadoop platform, and our relational platform in Exadata. And we're using that kind of model across it. So when we talked about the franchise model at the end, that's what we're doing. So actually, you can land data in Hadoop if it's quicker to do it that way. Often we're ingesting it relationally, calculating the measures in memory, managing the measures in memory, but the rest of the data flows through into Hadoop platform.
Two things in it. The business case. If you were to go to your business, you're talking about platforms and the cost associated with these platforms. Very interested in how you justify that initial spend. That's the first thing.
Slides?
Exactly. But the second thing is the size of your team. Annual budgeting. How do you justify the spend associated? Because you have to have some kind of measure, return on investment or whatever. So the business case. That's can we talk a bit about that? Business case first of all for the infrastructure.
Yeah, so that business case. So it's a sell exercise. So when our first venture into the data science thing, we effectively got the certain projects, certain interesting ideas, business problems, and we effectively got it in front of the exec, and we got it in front of Moyo and the team. And that's top level. So we effectively opened their eyes to what can be done here, and that straight away gives a little bit of capital. In fact, so much so that they actually made a decision that the priority on what the problems that data science should look at should come from the CSC and no one else. So effectively, we ended up getting some superb top-level backing straight away. Now, you can only live in that capital for so long, because then it's, well, okay, so what are you going to do? How are you going to deliver? How are you going to deliver? Yeah. Because when we first started, we were a little bit, but I showed you that team structure didn't really, they existed, but they were all over the place. And when we first put in data scientists, it was, okay, let's do a bit of play. Very quickly we realised, you touched this as well, but very quickly realised that you've got to sit it within a hopper system. So, there's 10 great ideas, and 5 of them might get to the CSC, 2 of them might get to business case, 1 of them passes business case. At that point, the rest of the development team kicks in, the rest of the engine kicks in, and then that puts it through. So that's the thing now. Traditionally, some business cases, we probably had to go say, we've got a really good idea. What does it explain? Why not something? Okay, so you've got to trust us on this, because it's a really great idea. Yeah, we've heard lots of great ideas. We've heard the word great ideas before. Whereas now we can actually say, look, you have got this. We've gone this data that you own. We've done this. Now we've done it. We've kind of cobbled it together. We've done it on proof of concept servers. We've got it together through a very manual level. But there you go. This is what you can do, and then that helps the business case in a way.
Then going back, time to market. Because you've got the CIO, he's got a load of mainframes, and you're coming along and saying, right, okay, you know what, we can extract the data, we can throw it into this, you've still got your master data, we can pull it off. I'm really curious about how you would sell that, especially as budgets are tight.
Well, frankly, that particular sale was done on a commitment basis. I mean, it was done on a handshake. About he, as a CEO, knew where he wanted to take the business. So we run workshops with customers, and we have 4 classic workshops. So we go from the kind of divergent, complex thinking workshop, innovation workshops for us, where it's business-led. The business knows that they want to leverage the information more. I mean, they understand that they want to do that, and they're frustrated about the lack of platform which will allow them to do it, frankly. I think what we have to be clever about, both with budgets and with those kind of things as well, is to make sure that whatever we're delivering, it's not lipstick on a pig. We can actually do platform underneath it as well. So you're delivering a kind of a drop of business value, but at the same time re-engineering platform to give you the longer term view. So for that we need to take enterprise architecture with us. We need to link that to business value and to the business that's driving it. But we also need to get governance in place. So for me, I mean, the thing that we haven't talked about is security, for instance, right? So, where does security happen here? Where does visibility of the data happen? Those things have to be thought through, but if we're not careful, it just becomes people saying, IT saying you can't do it, in which case the business is going to go and do it anyway. So, right, you've got to be really careful. And there's nothing more frustrating for us, actually, as an organisation, is customers saying to us, come and give us use cases for big data. I mean, really? You know, really? You just want a business case for big data? That's, you know, that's not working. I mean, it's got to be the business that are generating those, working with people like Paul. We're happy to help and support those things, but the business has to understand about how it can leverage information.
In effect, we learn the shadow IT. Everybody knows about shadow IT. Evil is the shadow IT is. Well, actually, it's not. It's fulfilling.
That's mode two.
It's fulfilling a role, absolutely. So we've actually learned from that. We've actually sort of looked at, well, how do they get access to senior people? How do they get access to the data? How do they actually do it? How do they do it quickly? How do they find out the relevant things to do to solve the problem? So we pick up that up. So thank you very much. Bring in a lot of smart people and we do it better. And that's what we found we've had to do. We've had to do shadow IT in this particular area. And if we're talking about a new HR system or a new parcel system, it's a totally different concept here. You know, that's kind of for full riggers of IT. But if we're talking about gaining value and insight from data, we have to outcompete the business IT.
You have to hug shadow IT. Keep your friends close and shadow IT even closer.
Learn from them.
Because they are the kind of people we're talking about. In fact, many of the tools and things that we're developing now, I mean, if you think about data scientists, there's a huge shortage. So there is a massive shortage of data scientists, and you think about that as a triangle, effectively, in that skill space. So if there's a shortage here, what we're really trying to do is make it simpler and quicker and easier for data scientists to do their work, so they can do more work. So they are jazzed by doing new research, not by munging data. So how can we automate those processes and simplify the processes? And we kind of talked about that. But at the same time, what we want to do is extend the capabilities of what business analysts are doing. So there are some business analysts who are exceptional at they understand the business, right? But they don't have the data science background. So giving them the tools to extend what they're doing up towards the data scientists, we think is really key. So we're building tools that help them do that.
So I did a project for 3 years working for one of these government departments, and the data scientists were all part of the business, they weren't part of IT.
Typical.
Okay, you're probably crossing a battle that myself and Tom's going to fight at the moment. And you're absolutely right, because as soon as you provide value, it's all the way to that. So we've already got part of that, the fact that the CDC directing the priority is a first step towards that. And we've been asked the same question. These guys should be sitting
Not the developers, but just the data scientists.
Now the argument worth going back to them is saying, yeah, you can pick up a data scientist and you can put them in a corner somewhere, or in a frontline business team, and they will give you value. Without a doubt, the smart people give them data, they're going to give you value. What we're saying is, if you put them in that support team that does all the other things as well, then they will develop more. They will get you get more value from them. Now, that's a little bit of trust me, I'm an IT person, it's not a conversation. So it is difficult, but that's the argument we bring forward, is putting them within that framework.
I think that operating model is up for grabs in the same way that BI went from being a COE model, centre of excellence model, to a competency centre model, and I think we're doing the same things at the moment.
Our BI team is in business.
Yeah,
so,
often it's the competency centre model.
Yeah.
I think one of the things you've got to ask yourself, most organisations, large organisations, banks, telcos, retailers, they have data scientists, but typically they're locked in as a very small, so they're doing churn management, or they're doing risk modelling, or they're doing whatever. They're not pervasive in the organisation. And what we're talking about, the Analytics 3.0 thing, is really talking about is how do we take that very small nugget, which is creating value for you, and spread it across the business. That's where you make more money. So if you get more at Paul's team, right, if you make money, you get more people, and you orientate your organisation around management by fact, you get more people, so that's what we're talking about, a journey, isn't it?
How do you see things like artificial intelligence or machine learning impacting the future of big data? Or would they replace data scientists?
Well, part of what Paul talked about was machine learning. I mean, so data mining, machine learning, and other aspects of that, right? So
we're doing that now. We're
Yeah.
doing that. That's those sort of techniques precisely why we brought these people on.
Artificial intelligence.
IBM Watson guys are doing a fantastic job.
AI is somewhat different to that, you know, knowledge discovery stuff. So it is slightly different in terms of the way that it's doing backward reasoning and things, but there's a place for that too. So, yeah, sorry.
So, thinking about your CBYT group,
Yep.
you know, if it's going to move and start to take on a bigger role across Royal Mail, what sort of new skills do you think that you need to add to that team so that it can actually facilitate that going forward? And is there any skills that you would want to drop from that?
Ooh, what new skills? I'm not too sure whether I want to add new skills or whether I want to do a scaling exercise. Maybe sort of draw it a little bit. Let me slight diversion and see whether I answer your question. Royal Mail is outsourced. It's a traditional outsourcer of IT. And we're slightly changed the model. We've just gone through all re-outsourcing. We've got some excellent partners on board, but as part of that, we started thinking to ourselves, we want to start doing a little bit more of this. So we've brought in architecture, we've brought in design. We're now considering, are we bringing in developers? So we have started that. So as part of the IT group, we're testing this idea of bringing in our own developers, and they kind of work side by side with our partners. So if I was looking to say, well, what extra capability? I'd probably look at, I always want more data scientists, I always want more data analysts, all those things, because it means we can do more. But what's keeping me awake at night, just sleep at night, keeping me awake at night, is how do we productionise that? So what I might be interested in is saying, well, how quickly, again, touching on what Doug was saying, how quickly can I take some of these great ideas and get them out into the wild in a safe, productionised manner? So curious enough, I might be looking at things like project managers, good testers, those kind of skills, the traditional skills that can supplement all the wild and wacky ideas that are coming from left field. So those are the kind of things I've been looking for.
Yeah, but isn't that a service you should consume from the rest of the IT function? You should go with it, right? It's like your developers. We'll have a chat about that later.
Yeah, maybe, but I'm a little bit sort of, you know, everybody's a little bit, you know, you get off my own resource, you know, I've got my own things to do.
It's a question of demand management, probably, actually.
Yeah. And also, I find that I'm echoing for you now, and no one does for years, and I'm ahead of a year now, but I'm coming from the data analyst, I'm a data guy through and through, and I actually think there's some specific skills around how we do things in data. So, for example, when I say testers, I'd be interested in testers that are very, very good at analysing data as well, not necessarily just generic testers, project managers that have done sort of things before. So people have been there, done that. I'd be
Just
interested
looking for data forensics type skills rather than just
Different
data
skills.
testers.
Data forensics, I still push towards a data scientist, but I'm more a case of just people that don't get scared with looking at large scale data, or you know, if I was to say, give you a good definition of data quality, or go in, those sort of people that know the language from it, that's the people like it.
So I'd like to draw it to a close. Thank you both very much. It was fascinating. Our next committee meeting, for those on the committee, is on the 19th of October. Daljit, do you want to talk about the Practitioners' Day very quickly?
Yeah, we're thinking of holding a Practitioners' Day. If you look at the activities that we've conducted in the past year, we've really been coming at it from a macro viewpoint. So what we want to do is we want to run a Practitioners' Day where we're covering off data architecture, we're covering off technology architecture, business architecture. We're looking for volunteers that are happy to run a session. And really it's about getting down to the low-level stuff, what kind of artifacts you need to produce, what are the kind of processes that you need to put into place. So we're looking for any volunteers and any kind of input into the kind of things we should be running on that day. But it is not going to be at a macro level. So when you're looking at a level 0 architecture, we want to get down to level 1, level 2. How do you actually do it on the ground? Yeah.
Any interest?
Any volunteers?
I think it's a great idea. Thanks for the subject, Sam.
Okay.
When is it?
We're planning to do it in November.
Yeah, it's November the 24th, same day as the Oracle Partners Day. So you have
Oh, this will be better.
if we can't fill a day, we'll probably go for a sort of cut down afternoon, evening
It
session.
won't be a freebie, we will be charged for it.
We're free.
So, and Sachin, you've got a presentation to make.
So I have
to
got
speak.
some gifts for the speakers for the excellent presentation. So please, these are BCS private pens. Thank you very much.
Thank you very much.
Very expensive.
Can I just say again, sorry, that if you download the presentation at the back end, there's the links to the website to register for that event we talked about. So if you're interested, please do.
So these slides will be loaded into BCS secure members area. So non-members would not be able to see it, unfortunately. So I would encourage a BCS membership so that you can see the slides and all that.
Great, thank you very much.
Are there drinks out?
Yeah.
There are.
There's drinks and sandwiches out?
Well done, sir.
Bring them along. Rather than having so people have a problem, come along, bring people, and they say, as a practitioner, I face this I think that interaction works really well. And I think we should start at 3 or 4 and go slightly. Do you know what I mean? It's a whole day, people can't afford the time.
No,